Hey guys, so today is a continuation of geometry. Today we're going to focus mostly on area and volume and parallel lines. So the ACT will not give you a lot of these formulas. These ones in this table you do need to know. So we all already know area is the inside of the shape, so that's usually like for a square or a rectangle, it's length times width. For a circle, this is one that isn't as common until you are pretty thorough with math, is pi r squared. Triangle is 1/2 base times height. Parallelogram also is a little bit different. It's just base times height. And then your trapezoid is not as common as well. It's 1/2 times your bases added together times the height. Now the height is always going to be the up and down. It's never going to be slanted. It's going to be perpendicular to the bases, meaning it's going to form a right angle with the base. And then your volume formulas, this is for your 3D shapes, is going to be length times width times height for anything rectangular. In a cube, length, width, and height are all the same because it's a 3D square, so it's just your side cubed. In a cylinder, it's pi r squared h, and then anything else is volume equals b times h, where b is the area of the base shape. So area of that base shape times your height, that gets you the volume. Again, the ACT will not give you most of these formulas. I would try to have them memorized. So let's go. The area of a square is 25 centimeters squared. If the square is enlarged by a factor of 2, what is the perimeter of the square? So first of all, I have an area of a square. Here's a square. I know that the sides are equal, so all 4 of these are exactly the same. Area of a square you get by doing base times height. In this case, they are the same, so I'm just going to call them side squared. Side. So side times side, area is side squared. Oh, that looks bad. Okay, so I know that the area of my square is 25 centimeters squared. That means that 25 is equal to my s squared, which means I can now figure out what my side length is. If I square root both sides, my side length had to be 5. So this is 5, 5, 5, and 5. So this is for my original square. Area is 25 centimeters squared. Your unit is squared for a square, just like with a cube or whatever, it would be cubed. And that allows us to find the side length. Now it says for this new one, it is enlarged by a factor of 2. So that means I'm going to take all those side lengths and multiply them by 2. They're all going to stay the same. They're just going to be multiplied by a factor of 2. So it's going to be 10, 10, 10, and 10. And it wants to know what is the perimeter of the new square. Perimeter is length plus width plus width. So length is 10, width is 10, and width is 10 since it's a square. So my perimeter is 40. Okay, so a lot of times they'll ask you about something, either area or perimeter, and give you the other one. So you have to be able to make that connection to go backwards, solve for that side length usually, and then use that moving forward. Okay, next. A woman has 2 rectangular gardens. The larger garden is 5 times as wide and 3 times as long as the smaller one. So she's got 2 gardens, this one and this one. So let's say wide and long. This is 5 times as wide and 3 times as long. If the area of the smaller one is x, what is the difference in the size of the 2 gardens? So here I know that area equals x. So we're going to kind of use a lot of letters here, which stinks, but that's okay. I have length times width, that's my area, is equal to x. Here I want to know what is this area. Well, again, area is length times width, but I have 5w times 3l, or 15wl. I already know that WL or LW is equal to X, so this is 15X, just basic substitution there. I was given that the area is X, so length times width is X. I can make that substitution happen. LW equals X or WL equals X, same thing, and then I just substituted it right here. There's a WL, plug it right in there. And it wants to know what is the difference. So you've got to do something different, no pun intended, different here. You're not just going to put 15X as your answer, even though that is one of the options. We are trying to look at the difference, so we're going to subtract them. So my bigger one minus my smaller one. My big one would be 15X. My small one would just be X, leaving me with 14X. Good. So that's some rectangles and squares. Here I've got more shapes. I've got a circle with a rectangle and a square. A square sheet of metal with sides 4A has a circle of diameter 2A and a rectangle of length 2A and width A removed from it. What is the area of the remaining metal? Okay, so all I want is what is in this bigger rectangle that is not the circle or the smaller rectangle. So you want to do big rectangle minus the circle minus the small rectangle. That means I need to know what all of these areas are. So area of the big rectangle, or I guess this is a square, would be base times height. In my big one, the base is 4A and the height is 4A. So that gets me 4 times 4, that's 16, and A times A, that's A squared. So that's going to go here, big rectangle. Next, I need the area of the circle. Well, area of a circle is pi r squared. What I was given is the diameter. My diameter is equal to 2A, which means my radius is half of that. My radius is just 1A, or A. So this is going to be pi times A squared. That is my circle. Unfortunately, it doesn't turn into a number, but that's okay. And the last one is my small rectangle. It's not in a different color. Base times height. That's how you find the area of that rectangle. So 2A times A is equal to 2A squared. So and that one is going to go in for the small. So to find the area of remaining, take your big, that is 16A squared, subtract your circle, pi A squared, subtract your smaller one, 2A squared, and combine like terms. Okay, they all have an A squared, however, pi A squared, I can't really do anything with. But I can do something with my 16A squared minus 2A squared, that is 14A squared minus pi A squared. I'm going to leave it just like that. I'm not going to combine my 14 and my pi. Here we go. The area of the figure above is blank. All right, so here we're putting together a rectangle and these semicircles. So area of rectangle plus both semicircles. So I have 2 semicircles. Or if you notice that you can put those semicircles together and create a regular circle, that'd be great too. All right, so I need to figure out what the dimensions of this shape are. I know the area, or the, I guess the length of this rectangle is 18. This is 18 and this is 18. It tells me that in the middle. That means I have 10 units because from one side of the arrow to the other is 28. I have 10 units to split between the circles. So that's 5 and 5. So this is going to be 5. This is going to be 5. That is your radius. Okay, so it's going from essentially the center of this circle to the outside. That's 5. Meaning this is 5, and then in your other circle, same thing, 5, 5, 5. My radius is 5. That means this portion right here is 10. This is 10. That allows me to get the area of the rectangle. Area of the rectangle is base times height, which is 18 times 10, or 180. And then my area of my semicircle, well, we know area of a circle is pi r squared. A semicircle is half of that, so cut it in half. So I have 1/2 pi. My radius is 5 squared, so I have 1/2. 5 squared is 25 pi. Now I have 2 semicircles, so I'm going to multiply this by 2. 2 of my semicircles is 2 times 1/2 times 25 pi. Well, thankfully, my 2 and my 1/2 will cancel out, and I'll just have that 25 pi left. So if I want the area of this whole shape, I just need to add them together. Area of the rectangle plus area of my 2 semicircles. 180 plus 25 pi. Here we are, G. All right, I think we got one more in this. Yes. Okay, so this one says, I have this like kind of offset figure here. All segments of the polygon meet at right angles. The length of AB is 10. The length of BC is 8. The length of DE is 3 and GH is 2, and we want to find the whole perimeter. So I want to add up all my sides. Okay, so I can tell a few things from here. I can tell that this whole portion from here to here is 8 plus 3, that's 11. That means this whole portion over here is also 11. I don't need to really figure out what F to whatever that letter was, FG, and then HA is. It is the same up and down distance of 11. Same thing with the top and bottom. Top, this whole portion is 12, right? This 2 and this 10 gets me 12, which means that this whole portion put together will also be 12. All you have to do is make sure that you've accounted for every little inlet that there is. Once you've done that, it's basically just a rectangle. So I have 12 for the top and 12 for the bottom, and then 11 and 11 for the sides. That did take care of, I'm going to move these off, just so that I can make sure I've accounted for every side. That did take care of this and this, that was 12. This bottom and this bottom, that is 12. This side and this side, which is 11, and this side and this side, which is 11. So as long as you've taken care of every little divvy in, you're good. So I have 12 plus 12 plus 11 plus 11, that's 24 plus 22, or 46. So the diagram is a little bit misleading. All right, well, it just looks harder than it is. All right, line geometry, this is the big one. All right, so this has a lot to do. You have 2 parallel lines. My 2 parallel lines are right here, and they're cut by this transversal. Transversal means it goes diagonally through the other lines. So that creates a lot of angle pairs. You can pause and read this. You have supplementary angles and linear pairs. They make straight lines. They add to be 180. So like 1 and 2, 6 and 7, 4 and 3, 5 and 8. Any set that's going to make a straight line, it could be 3 or 4 angles put together, but as long as it creates a straight line, it's equal to 180. I have listed the pairs there. You have vertical angles, which are across from each other, created by intersecting lines. So here are my intersecting lines. The angles across from each other are vertical. I know this looks like a little spaceship, but that's okay. Those are also going to be congruent, which means that they're the same. We have alternate interior angles made from that Z structure. So here is where the Z will be. Here, here, and here. Those angles are this one and this one. Those are the same, the ones on the inside of the Z. So that would be 4 and 3, and then the Z, we could kind of draw it the other way, even though I know that's not right. 3 and 5. Those would also be congruent. And then we have corresponding angles, which are basically the same angle in a different location. So like 1 and 5. These are the same exact thing, just kind of move down on a step. Those are also congruent. You do need to know these relationships in order to be successful on this portion of the ACT, so I have them listed here. You can, again, pause and write this down if you want. I would advise to do that. That way you can use it moving forward. All right, what is the value of x in this figure? So I am going to notice that I have two sets of parallel or a set of parallel lines here and here. That isn't necessarily stated, but that you can pretty much assume that. You can also tell that you have two intersecting lines which create vertical angles. So whatever angle this one is going to be the same here. That's 60 degrees. Now I can use the information that I know about a triangle and find x. I know that every single triangle, the angles of it add up to 180. So I have 40 plus 60 plus x to be the inside of that triangle. So 180 is equal to 100 plus x, so x is equal to 80. Pretty straightforward using that vertical angles fact that those are congruent angles, and then remembering that the angles of a triangle add up to 180 degrees. All right, in this one, in the figure, L1 and L2 are parallel and L3 is a transversal. What is Q minus P? So I got to figure out what Q and P are. Let's see, this right here is 135. So what can I tell from that? I can tell that this angle here is going to be 135 degrees because it's a corresponding angle. Okay, that gives me a little bit. Now I can recognize that this is a straight line. Every straight line adds up to 180. So 180, it's got to be 135 plus P. Okay, that allows me to find out that P, if I move this, P is equal to 45. Okay, so that gives me one angle. Now I need to find Q. Okay, Q is going to be the rest. I'm just going to kind of change my orientation here, because Q, if I look at this, I've got another straight line. 180 is equal to P plus Q, 45 plus Q, which means that when I move this 45, Q is 135. So now I know Q, I know P, I could do Q minus P. 135 minus 45 gets me a 90, not a 40, 90. Good. And again, that's just knowing the angle relationships, being able to jump from corresponding angles. Then you could have even used vertical angles to figure out what Q was right away. And then using the supplementary angles or linear pair relationship, that will allow you to be able to kind of fill in these missing pieces. All right, in the figure below, A and B, A, B, and C, D are parallel lines. R, S, and P, Q are straight lines. What is true? So these two are my parallel lines. That's important to know. And then we're going to look at this kind of separately. What is true? So G and Z, those are equal. I'm just going to go through each answer. G and Z, are those equal? Well, based on where they are, first instinct is to think corresponding angles. However, they jump from one transversal to the next instead of one parallel line to the next. So those two are completely separate angle relationships. Look at this one separate and this one separate. I cannot relate anything from the blue side into the purple side, so it is not going to be A. Next, G is equal to X. G and X. Again, two completely different scenarios. You're looking at two different sides of that diagram, so you cannot make any relation there either. You cannot jump from parallel line like that. All right, G is equal to Y. G and Y. Same exact thing, jumping from one parallel line to the, or one transversal to the next. You cannot make any relationship there either. Your rationale would be that G is equal to W, which corresponding, if these were all parallel, would be equal to Y, except those two up and down lines are not parallel, so we can't assume that either. G is equal to E. Okay, these are on the same set. They're both in the blue box, so let's play a little bit with this. You've got G and E. G is going to be the same as W. That's because those are corresponding. Okay, so now can I make W and E the same? Because if G is equal to W and W is equal to G, then G is equal to E, and we found our true statement. So are W and E equal? Yes, they are. They are vertical angles. So therefore, that is our answer. Good. All right, I think this is our last one. Yep. Solve for X. Okay. So the only thing that I see here, I mean, you see a lot, but something that could really stand out for you is this straight line. I know that every single straight line is equal to 180 degrees. So if I add up all of these parts, I should get 180. Now, the only thing that's missing is that middle portion. I know I've got 3x and 80. I need this. So this 2x here is going to help me. That is going to be a vertical angle to the one that's missing. So I can add in that 2x here. Now I can solve for x. Again, the fact that I knew that this was a straight line, and every straight line, the angles that create it, or that form it, are going to be 180 degrees, that benefits me so much. And then you can, again, make that relationship pair that the missing angle and 2x are the same. And now I can just combine my like terms. 2x plus 3x is 5x, plus 80 is equal to 180. Solve for x, subtract the 80. 100 is equal to 5x, and now isolate the x, divide by 5. X is 20. All right, if you have any questions, let us know.